Hello everyone, good morning. Hello everyone, good morning. How are you today all? Yeah, so today we are going to start with our next topic, that is mole concept and solutions. Hello. Hi. Good morning. So everyone is joined. So now let's start with our session. Okay. So today we are going to start with the mole concept and solution. So here you can see I have summarized certain things in this PPT. Okay. Molecular mass relations and everything. Right. So before jumping into the previous year questions of mole concept, see here number of moles you can calculate, number of molecules you can calculate, mass in grams you can calculate by just remembering this diagram. Okay, but by just remembering this given diagram. If you have given mass in grams and you want number of moles from that, just divide it by molecular mass. Okay. If you have given number of moles and you need to calculate the number of molecules, just multiply it by the molecular mass. So follow the arrow here. Okay. Next, here I have summarized the solution colligative properties. Okay. So now let's first of all start with the mole concept. So the mole concept is very, very important because in every examination, one question or two questions are always asked about the mole concept and they are very easy to solve. Okay, once you get the idea, you will be easily solving such type of questions. So now see here, mass mole volume at STP, mass mole volume at NTP. So this is what NTP, normal room temperature, or you can call it as room temperature and pressure. NTP, normal temperature and pressure. Okay, so यहाँ पे if you have given moles, okay, and you want to find out the volume of a gas, just multiply it by 22.4. If you have moles and you want mass, just multiply it by the atomic weight of a given atom or molecular weight of a given molecule. Just like that, I have shown here mass mole volume relationship. This is mass mole volume relationship at NTP. Same is the case. Just here 22.4 instead of that, here only 24 is present. Okay. So now let's understand this concept according to the certain. Let's solving by certain PYQs. Okay, previous year questions. So first question is here, you can see which one of the following will have the maximum number of atoms. So you know that 1 mole of atom, 1 mole of substance contain how many number of atoms? Avogadro's number of atoms, right? 1 mole of a given substance contains Avogadro number of atoms. So here we have given the atomic mass of silver, magnesium, oxygen, and lithium. Okay, these are given, so that's why we are going to consider these atomic masses of these atoms. Okay, so 1 mole of a given compound will give us the Avogadro's number of atoms. So here, what we need to find out, 1 gram. How much? 1 gram of a given atom will give how many number of atoms, and out of these 4, which will be having maximum number of atoms. So first of all, for first option, let's try it out. What will be the number of atoms here? So for 1 gram of Ag, the number of atoms will be how much? So you know that 1 mole of substance is nothing but the atomic weight or molecular weight of that given substance, right? Atomic weight or molecular weight of that given substance. So here, what is the atomic mass given for Ag? So 108 gram of Ag will contain how many number of atoms? Avogadro's number of atoms. But here what we have asked? We have asked 1 gram, right? So 1 gram of Ag will contain how much? Just do the cross multiplication. You will be good to go and solve this given problem. So X is equal to what? Na divided by what? 108. These were the number of atoms present in 1 gram of given compound, right? In 1 gram of given substance. Any doubt in this? Yes, यहाँ पे क्या आएगा? 1 gram of compound or 1 gram of Ag will contain Na upon 108 number of atoms, right? Simple है. Similarly, you can do this for second option. And in this way, you need to calculate for each option. So for second, 1 gram of magnesium. So molecular weight or atomic mass is given to us 24 gram. Mg will contain the Avogadro's number of atoms. So 1 gram will contain how much? Na upon 24 gram. Okay, Na upon 24 number of atoms. This much number of atoms, it will be present in the 1 gram of magnesium, right? Next, what is given? 1 gram of O2 is given. Okay, and for that, atomic mass of oxygen is given. Okay, but this is mass of oxygen. Here, molecule is given, that is O2. So what will happen? For O2 molecule, there will be 32 gram will contain any number of atoms, right? 32 gram will contain any number of atoms. So atom, how many atoms will be present here? 32 gram will contain any number of atoms. So 1 gram of O2 will contain how many? 1 gram of O2 will contain Na upon 16 atoms, right? Na upon 16 atoms. So this is about oxygen. For lithium, what will be the case? For lithium, 7 gram of lithium will contain Avogadro's number of atoms. So 1 gram will contain Na upon 7 atoms. Okay, whatever the calculation will come, that will be the answers. So you can observe here that what is happening is Na is divided by certain things. 16, यहाँ पे 7, यहाँ पे 108, और यहाँ पे 24. So which will give us the maximum number of atoms? If denominator is small, then the term will be higher, right? So our fourth option, in which lithium, there is its atomic mass is 7 only. So Avogadro's number, you know what is that number? 6.023 into 10 raised to 23. Or 6.022 into 10 raised to 23. This much number of atoms are present in the given Avogadro's number. Okay. So यहाँ पे आंसर क्या होगा हमारा? कौन सा ज्यादा से ज्यादा atoms मिलेंगे? In which case we are going to get a more number of atoms, maximum number of atoms. Option D. Okay, because Na is getting divided by a smallest number. So that's why 1 gram of lithium has maximum number of atoms. Any doubt in this? Yeah, I have shown the solution also. Next problem. In which case is number of molecules of water maximum? So now we have given water molecule specific, okay, and the volume, here is volume given, here what weight is given, in third one volume is given, and in next one moles are given, okay. And now we need to find out number of molecules. So in order to find out the number of molecules, now first of all, what we are going to do is, we are going to do one by one options, okay. First is what? 18 ml of water. So we have given 18 ml of water and we need to find out number of molecules. So what is the formula for number of molecules? See, we have seen here. Number of molecules, if we need to calculate, okay, what we have to do? We have to divide number of moles by molecular weight. We need to divide number of moles by molecular weight. So here what I am going to do for this, first of all, volume is given, that is 18 ml. From this, I can calculate the mass of water, right? What is mass of water? You know density. Density is equal to mass upon volume, right? So here mass will be equal to volume into density, and volume is given to us 18 and density of water is 1. So what will be the mass of water here? 18 gram. Okay, now we have the mass of water. So what I'm going to do here is, let's calculate molecules of water. Molecules of water is equal to, what will be that? Number of moles into Avogadro's number. And what is number of moles? Weight upon molecular weight or atomic weight for a given component, multiply by this one. So what is weight given? 18 gram. What is molecular weight of water? 18. And number of atoms will be like this way. So what will be our answer here? Avogadro's number will be our answer, right? Okay. See, for second case, what will be the case? Molecules of water. So here moles into Na. So how many grams are given? 0.180 gram divided by 18 and you multiplied by Na. You will get this much amount of Avogadro's number, right? Same है, mass दिया था, okay? For next one, water volume is given, okay? So moles of water will be equal to, you know the formula. Just I have shown you the formula for calculating the moles, right? See, moles and volume divided by 22.4. You will good to go, right? So right now, यहाँ पे क्या किया मैंने? In order to calculate the moles, I have divided the whatever volume is given to me by 22.4. So like this way, you will get the moles. Multiply those moles by the number of Avogadro's number. You will get the maximum molecules. Okay, you will get the molecules. Molecules of water, moles into Na, 10 raised to minus 3 Na. So which is great? It is Na, which is a good, which is a maximum amount. Where we are getting the maximum number. Na यहाँ पे है, यहाँ पे 10 raised to minus 4 Na है, यहाँ पे 10 raised to minus 2 Na है. So यहाँ पे क्या है? Na. यहाँ पे 10 raised to minus 2, 10 raised to minus 4 and 10 raised to minus 3. So what will be the correct answer here? Yes, A, B, C, D. क्या यहाँ पे क्या आएगा? सबसे ज्यादा maximum number किसमें? यहाँ पे है. So that's why our answer will be option A. Any doubt in this? Okay, do you get the idea of how to calculate the number of moles, molecules? Right? Very good. Number of atoms? Yeah, very good. Now let's move on to the next question. Suppose the elements X and Y combine to form two compounds XY2 and X3Y2. When 0.1 mole of XY2 weighs 10 gram and 0.05 mole of X3Y2 weighs 9 gram, the atomic weights of X and Y are. So here we need to find out the atomic weights of X and Y if all this information is given to us. So let's suppose the atomic weight of element X is X and Y element is Y. These are the atomic weights. Okay, let's suppose that. So for XY, what is given? Number of moles are given. What are those? 0.1 moles are given. Okay, and for second, 0.05 moles are given. And out of that, the weights of their respective components are given, 10 gram and 9 gram. So let's substitute all these values. So here number of moles is equal to what? Weight upon molecular weight. Weight is given 10. Molecular weight, how much? It will be X plus 2Y because compound is what? X, Y, 2. Okay, so X plus Y will be equal to 10 upon 0.1. So it will be equal to 100. Okay, this is what we get one equation, equation number 1. Secondly, for X3Y2, what is given? 0.05. Number of moles, weight is given 9. You can calculate the molecular weight like this way, 3 times of X plus 2Y. So you will get the another equation, 3X plus 2Y equal to what? How much? It is equal to 180. This is equation number 2. Solve this equation, you will get X is equal to 40 and Y is equal to 30. Okay. X is equal to 40 and Y is equal to 30. So that's why here correct option will be option A. Right? Any doubt in this? Very simple problem. Okay. We just have to form the equations here. Okay. Molecules, number of moles were given as well as weight was given. You can easily find out X and Y. Okay. Shall I move on? Okay. Next problem. The Avogadro's number is changed from this. Okay. 10 raised to 23 to 10 raised to 20. This would change the mass of 1 mole of carbon, the ratio of chemical species to each other in a balanced equation, the ratio of elements to each other in a compound, the definition of mass in units of grams. So here what will be changing? Avogadro number is changed. Then what will change? The mass of 1 mole of carbon, ratio of chemical species. What will change here? Since you know the Avogadro's number has been set according to what? Carbon. Okay, according to carbon. So mass of 1 mole of carbon is equal to 12 gram, right? Mass of 1 mole of carbon is equal to 12 gram. And 1 mole of carbon is nothing but how many numbers of atom? Any number of atom, and that is 6.022 into 10 raised to 23, right? This much atoms is equal to 12 gram. So if we are changing the Avogadro number, then what will change? Mass of 1 gram, 1 mole of carbon will change. That's why the answer will be what? Option A. Okay, the definition was this one. Okay, so if Avogadro's number is changed by this much atoms, then 1 mole of carbon will, see, 12 into 10 raised to minus 3 gram. If 6.022 into 10 raised to 23 gives us 12 gram, then 6.022 into 10 raised to 20 will give us how much? So just do this cross multiplication. You will get the idea that 1 mole of carbon, first of all, was 12 gram. But when you change the number of atoms, 1 mole of carbon changes to 12 into 10 raised to minus 3 gram. So this is our correct answer. Option A. Right? Any doubt? Okay, so let's move on to the next problem. Number of gram molecules of oxygen in CO molecules is. So यहाँ पे we need to find out the number of gram molecules for oxygen. Okay, in a CO molecule. So you know that Avogadro's number, you know the value, that is what? 1 mole of given compound, right? 1 mole of given compound. So right now here we have given certain number 6.0. I will write here 6.02 into 10 raised to 24. Okay, this much CO molecules will be equal to how much? Since 6.02 into 10 raised to 23 equal to 1 mole, this much will equal to how many moles? 10 mole. Okay, 10 mole of CO. 1 mole of CO. This will be what? 10 mole of CO. So 10 gram, okay, 10 gram of O will be equal to how much? 5 gram molecules of O2. So here what will be the answer? Here answer will be our option. कितना ऑप्शन आएगा? 5 ग्राम कहाँ पे लिखा है? B में. ठीक है? So our option will be correct B. Okay? Any doubt in this? समझ में आया क्वेश्चन? आंसर? एक्सप्लेनेशन? Yes, 10 gram of atom is equal to 5 gram of molecules of O2. Okay, next. A mixture of gases contains H2 and O2 gases in the ratio 1:4, weight by weight percentage. What is the molar ratio of the two gases in the mixture? So here we need to find out the number of moles of H2 as well as number of moles of O2. Then we will get good to go to find out the molar ratio of the two gases in the mixture. So from the given data, we can calculate that number of moles of H2 are 1/2 and number of moles of O2 are 4/32. Just put these values and you will good to know about the what will be the molar ratio of a given H2 and O2. So यहाँ पे option कितना आएगा? Answer कितना आएगा? Okay, can you tell me the answer? Yes, mixture दिया हुआ है, H2 और O2 gases है, उनका ratio 1:4 दिया हुआ है. What is the molar ratio of the two gas in the mixture? Yes, number of moles यहाँ पे मैंने दिए हुए हैं. What will be the answer? Here the answer will be 4:1. Okay, just put the number of moles value. Yeah, and you will find out the answer. Okay. Next, which has the maximum number of molecules among the following? Okay, now we have given the weight of every molecule. Okay, CO2, H2, O3 and SO2. And we need to find out what maximum number of molecules. So do the calculation similarly like molecules, number of molecules is equal to moles into Na. So when you do all those calculations now, first two questions we have solved like that way, you will find out that the option C, that is 8 gram of H2 will have highest, right, maximum number of molecules. Okay, since 8 gram of H2 will have 4 moles. Okay, 4 moles, while other all will have 1 mole. Everyone is having 1 mole, 1 mole, 1 mole. And that's why our correct option will be 8 gram of H2. ठीक है, इसका एटॉमिक वेट निकालो, इसका एटॉमिक वेट निकालो, इसका एटॉमिक वेट निकालो, आप लोगों को नंबर ऑफ मोल्स मिल जाएंगे. वेट अपॉन मॉलिक्यूलर वेट. ओके, मॉलिक्यूलर वेट निकालो सबके, आपको नंबर ऑफ मोल्स सबके 1 आएंगे. लेकिन यहाँ पे व्हेन यू कैलकुलेट द नंबर ऑफ मोल्स फॉर दिस ऑप्शन सी ना, you will find out that 4 moles you are getting. So that's why our correct answer will be C, 8 gram. Right? Next problem. The number of atoms in 0.1 mole of triatomic gas. So here, gas is not triatomic. So what will be the formula? Number of atoms will be equal to Avogadro's number into number of moles, right? Into 3, because the gas is what? Triatomic gas. So you know the Avogadro's number, put the value 6.022 into 10 raised to 23. Number of moles, how many given? 0.1, and multiply it by 3. You will get the all the number of atoms. Okay, all the number of atoms present in the given compound. So if gas is given, whether it is monoatomic, diatomic or triatomic, then feel the, see, यहाँ पे ये होता है, ठीक है, atomicity होती है, number of atoms calculate करने के लिए, right? So here our answer will be what? A, B, C, D. What will be our answer? Our answer will be option B. Okay, right. Next problem. Ratio of Cp and Cv is given. So we have given Cp by Cv ratio, that is 1.4 for a given gas X. Okay, which shows that the gas is what? Since this ratio is 1.4, this gas is what? Monoatomic or diatomic? This is what? Diatomic. Okay, present 11.2 liter of it at NTP will be. Okay, so यहाँ पे हम लोगों को दिया है कि number of atoms कितने present होंगे. We need to calculate the number of atoms. So you know that 22.4 liter contains what? How many number of molecules? Na number of molecules. So here 11.2 liter will contain how many number of molecules? Divided by 2. Right? This much number of molecules will be present. But now we got the idea of number of molecules. We need to calculate here number of atoms. So right now we have find out. Right now we have previous question we have seen that we need to multiply it by the what? We need to multiply the number of molecules with the atomicity. So here atomicity is what? 2, because atom is what? Diatomic. So Na by 2. So this much number of atoms will be there. So calculate this. You will get the answer like this way. 2 into 3.01 into 10 raised to 23 atoms. We will get 6.02 into 10 raised to 23 atoms. That is which option? Option number A. Right? Any doubt in this? Very simple, simple. Okay. Next problem. 1 cc N2O at NTP contains. So normal temperature and pressure 1 cc. How much it is going to contain? This much number of atoms, this much number of molecules, this much number of electrons, or all of the above. Okay, or all of the above. So we need to calculate this. So see here answer. As we know, 22400 cc of N2O contains this much number of molecules. Cc means what? Cubic. Yes, cubic centimeter. Okay, so 1 cc will contain how many number of molecules? Divide Na by this much volume, you will get this much number of molecules. So since N2O molecule, there are 3 atoms, right? Its atomicity is what? 3. So multiply it by 3, you will get this much number of atoms. So that is what? Number 1 option. Right? So number of electrons in the molecule N2O, how many? 7, 7 plus 8. So 22 electrons will be present there. Okay. So what is given to us? Hence number of electrons in 1 cc of N2O will be 1 cc में कितने होंगे? Multiplied by 22, you will get the answer this much electrons. So this is again correct. And 6.022 molecules present. Okay, yeah, this is also correct. So all these are correct. So our answer will be what? All of the above. Right? Are you getting this? Fast नहीं ना हो रहा है? समझ में आ रही है बात? Right? 1 cc of N2O. So atomicity, how many atoms are present? 3 atoms. These are 2 and this is 1. So 3 atoms are present. That's why we are multiplying. In order to find out the number of atoms, we are multiplying it by the 3. Okay. Any doubt in this? Yeah. Okay. Next problem. particle is this much, whose radius and length are given to us. Find out the molecular weight of a given virus. So this problem was somewhat bigger problem, okay, and it needs more calculation. So see here what will be the answer. So we have given the specific volume for a cylindrical virus particle, that is this much cc per gram, okay, whose radius is given, length is given, okay, radius is what, r is equal to 7 angstrom, and its length is what, 10 angstrom. So 7 angstrom I have converted into centimeter. So you know volume of virus is equal to pi r square L, because it is a cylinder. The volume of cylinder is what, pi r square L. So pi ka value 22.7, or you can put 3.14 also. R ka value I have written 7 into 10 raised to minus 8 centimeter square. L is what, length. Write down the length. It is also in angstrom. I have converted it into centimeter. You will get the volume in terms of cc. As soon as you will get the volume, we need to calculate the weight, because we need to find out the molecular weight. Okay. So weight of one particle will be what, volume divided by specific volume. So volume you have calculated divided by the specific volume which was given in the problem. You will find out in the next step, molecular weight of a given virus is equal to weight of any number of particles. So whatever the answer you are getting here, I have multiplied it by any amount. Okay, that is Avogadro's number. You get answer in gram per mole, and in the options, the answers are given into kg per mole. That's why multiply it by 1000, you will get 15.4 kg per mole your answer. That is option A is your correct answer. So this was a different problem. The method was asking, to calculate the molecular weight was different, but we need to find out the same way. We need to follow the same way. Molecular weight is equal to weight of any number of particles. Okay. Very nice question. Next, the number of atoms in 4.25 gram of NH3 is. So यहाँ पे NH3 molecule दिया हुआ है, and we need to find out how many number of atoms will be present. So can you tell me the answer? 1, 2, 3, 4. NH3. Find out its atomic weight. Yes, 14 plus 3. It will be 17. Right? 14 plus 3. It will be 17. Right? So see the answer. 17 gram of NH3 will contain 4 Na atoms. Okay, the number of atoms in 4.25 gram of NH3 is approximately 4 Na atoms. So this much gram of NH3 will contain, divided by 17, multiply by 4.25, you will get the number of atoms here. Okay, you will get the number of atoms here. So in this way, you need to calculate the number of atoms. Okay, number of molecules, which is going to have the maximum number of molecules, which is going to have the maximum number of atoms. So this is all about mole concept. ठीक है, समझ में आया है सबको? Yes. Now let's move on to the next topic, that is what our solutions. Okay, so when we talk about solutions chapter, it is very, very important chapter because it contains so many important topics like colligative property. So you know which are the major colligative properties. So colligative properties are what? Relative in lowering of vapor pressure, elevation in boiling point, right? Relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. So what are actually the colligative properties? These properties of solution depend on the total concentration of all the solid particles, regardless of the ionic or molecular nature, charge, or size. Okay, number of particles, number of molecules in the solution of non-electrolytes, and number of ions. It is directly proportional to all these things. So colligative properties are very, very important. The first one is relative of lowering of vapor pressure. You know the formula. Remember the formula. Next, elevation in boiling point. Remember the formula. Depression in freezing point. Remember the formula. Okay, how to calculate it, how to determine the delta TF value. Next, osmotic pressure is a hydrostatic pressure produced when a solution is separated from the solvent by semi-permeable membrane. You know osmotic pressure. What is that? Pi is equal to CRT. Okay, what is C? C is the concentration. Okay, pi is equal to CRT. Okay, and by using this equation, we can easily find out the pi value, that is osmotic pressure. Okay, any doubt in this? Next, so when we talk about solutions, there are two types of solution. ideal solutions and non-ideal solution. Okay, there are two types of solution, ideal solution and non-ideal solution. So what are the ideal solution? Which obey the Raoult's law. Which obey the Raoult's law are known as the ideal gas equation. Which obeys the Raoult's law are known as the ideal gas equation, and which do not obey the Raoult's law are known as non-ideal equation. So these are the non-ideal equation which show positive deviation and other are showing negative deviations. Okay, when V mixing is 0, total volume of solution is equal to the sum of the volumes of the components. Here, when V mixing is greater than 0 and V mixing is less than 0, here increased after dissolution, decreased during dissolution. Okay, यहाँ पे neither heat is evolved nor heat is absorbed. Here endothermic reaction, here exothermic reaction. This chart is very, very, very important. Okay, AB, such type of, or BB, any kinds of molecular interaction present in the two liquids should be same. All should be same, since molecules are in the identical shape and sizes. But here what is happening? AB force of attractions are less than the AA and BB attractive forces because of their different shapes and size. And here AB force of attractions are greater. यहाँ पे less consider किया है और यहाँ पे great consider किया है, ज्यादा consider किया है. ठीक है, और इस तरह से escaping tendency of A and B in the same pure liquids, okay, सेम रहती है. escaping tendency यहाँ पे high होती है और यहाँ पे क्या होती है, low होती है. Examples ढूंढो लिख लो. ठीक है, क्वेश्चन आता है इथिल ब्रोमाइड प्लस इथिल आयोडाइड, दिस इज विच टाइप ऑफ सॉल्यूशन, आइडियल सॉल्यूशन, नॉन आइडियल सॉल्यूशन. ओके, so these are what ideal solution. Acetone ethanol is a non-ideal solution. Acetone aniline is a non-ideal solution. Okay, next, quantum factor. So this is again very, very important in order to understand the dissociation and association regarding the solution. Okay, so when there are certain solutes which undergo dissociation or association in the solutions, they are found to show abnormal molecular mass. Thus, in order to know the extent of association happen or dissociation takes place in the solution, Wontaff was a scientist who introduced a factor, that is I, and it is defined as normal mass to the observed molar mass. Normal molar mass to the observed molar mass is known as a Wontaff factor I. And you know that molecular mass is inversely related to colligative property. So that's why it changes all the colligative properties. So observed colligative property divided by normal colligative property. And what is I? Total number of particles after association or dissociation divided by number of particles before association and dissociation. Okay. So these 3 points are very, very important. 1, 2, and 3. When I is equal to 1, solution remains unaffected. Solution is normal. When I is greater than 1, solution undergoes into dissociation. When I is less than 1, solution undergoes into association. So these 3 points are very, very important. Next, let's talk about the solubility. Solubility is what? Maximum amount of substance that can be dissolved in a specified amount. Solubility of solid in liquid, solubility of gas in liquid. Okay, so these are the certain things. Henry's law we use when gas is dissolved in the liquid. Okay, like dissolvents for solid in liquid. Okay, next, Raoult's law, which is very, very again important. Okay, that law is for vapor pressure of pure 2 constituents. Okay, vapor pressure in order to calculate the total pressure. Okay, total pressure is equal to, it is a sum of partial pressures or vapor pressure of a given liquids. Okay, next, not liquid, for gases. Okay, partial pressures of gases, vapor pressure of pure state of 2 constituents A and B in the given solution. So now types of solution. Which type of solutions are there depending upon their physical state? Gas in gas, air. Gas in liquid, soda water. Gas in solid, hydrogen. So these are the classification according to their physical state. I have done the types of solutions. Smug क्या है, alloys क्या है, ठीक है, alkaline water क्या है, what liquid in liquid, amalgam क्या है, liquid in solid, like that thing. So classification based on the concentration. There are different types of solution: dilute solution, concentrated solution, saturated solution, and supersaturated solution. So you know these, right? Dilute solution means what? The concentration of solid is less. Concentrated means what? Concentration is high. Saturated means what? Very, very high. That insoluble particles of solute particles are present there. Okay. Supersaturated means after saturation, if you go on adding the if you go on adding the solid particles, now what will happen? The solution will become super saturated one. The solid will not dissolve into the solution. That is known as a super saturated solution. Next, there are certain concentration terms which we have learned into the mole concept also. That is some basic concepts of chemistry, right? Mass percentage, molarity, molality, normality, mole fraction, volume percentage, ppm, mass by volume percentage, all these things. So percent, ppm, mole fraction and molality are independent of temperature. So these are independent of what? Temperature. Okay, very, very important things. Solutions, very, very important key points to remember. Now let's solve some PYQs on this given chapter. So first of all, which of the following is dependent upon temperature? Yeah, which will be dependent upon temperature? Just now we have talked that molarity will be dependent on temperature. Other three are what? Independent of temperature. So our answer will be option A. Okay, our answer will be option A. Next problem, problem number second. How many grams of concentrated nitric acid solution should be used to prepare to 50 ml of 2 molar HNO3, the concentrated acid? So यहाँ पे हम लोगों को molarity या molality पे से कौन सी तो भी concentration term we have to use, right? So we need to use here which type of quantity? So we will going to use here molarity. Okay, molarity. What was the formula? Weight, number of moles of the solute present in the what? 1000 liter of given, right? 1 liter of a given substance. See, molarity, you can see the definition here. Molarity, number of moles of solute in volume of a solution in a liter. 1 liter volume of a solution. So यहाँ पे हमको molarity का formula use करना है, number of moles into volume. But number of moles क्या होते हैं हमारे? Weight upon molecular weight, right? So यहाँ पे आ गया volume. अगर हम लोगों को वॉल्यूम ml में दिया हुआ है तो हमको यहाँ पे क्या करना पड़ेगा? इस इक्वेशन को मल्टीप्लाई करना पड़ेगा 1000 से. So that's what I have done here. So we have given the weight, right? No, we need to calculate the grams. We need to calculate the weight. Okay, molarity is given, that is 2. Weight is given. Okay, 2 is equal to weight हमको निकालना है. हमको दिया हुआ है molecular weight. Multiply करो इसको 1000 से. Volume भी हमको दिया हुआ है, that is 250. Just do this cross multiplication and you will find that W is equal to 63 by 2. Okay, W is equal to 63 by 2. Okay, so what will be the mass of acid? 63 by 2 into 250 by 1000. Okay, into 250 by 1000. So here you will get answer W is equal to 45 gram. Okay, यहाँ पे थोड़ा ये प्रिंटिंग मिस्टेक हो गया है. Okay, W is equal to what? 63 by 2. Okay, any doubt? Yeah, next question. In water saturated air, the mole fraction of water vapor is 0.02. If the total pressure of the saturated air is 1.2 atm, the partial pressures of dry air is. So here, what will be the correct answer? Okay, we need to calculate the total pressure, right? So here, pressure of water vapor is equal to mole fraction into pressure of total pressure, right? We need to use here Raoult's law. Okay, so see here, what will be the answer? Water vapor is equal to mole fraction into total pressure. So mole fraction is given 0.02, total pressure is given 1.2. So this will be the vapor pressure of water vapors. Okay, so total pressure is equal to what? Vapor pressure of water plus vapor pressure of dry air. So both the terms we know, we can easily calculate for the dry air. So partial vapor pressure is directly proportional to mole fraction. That is the relation we have used here. So what is the answer? 1.176 atm. That is option C is correct. Okay, that is option C is correct, right? Okay, so यहाँ पे option A रह गया है 1.5 atm. Sorry, okay. So what is the correct answer? 1.176 atm is the correct answer. In this way, you need to calculate the. Okay, next, PA, PB are the vapor pressures of pure liquid components A and B of an ideal binary solution. XA are the mole fraction of component A. Total pressure of the solution will be. So here, according to Raoult's law, we need to calculate the equation. Okay, so you know, according to Raoult's law, what is Raoult's law? Total pressure is equal to mole fraction into vapor pressure plus mole fraction into vapor pressure of another component, A component plus B component. Okay, and you know, mole fraction of A plus mole fraction of B is equal to 1. And you can rearrange this equation like this way also. So just putting these values in equation this, you can easily find out the answer. So here what? PB plus XA, PA minus PB. So total pressure will be what? Partial vapor pressure plus mole fraction into vapor pressure minus vapor pressure of component B. ये प्रॉब्लम हम लोग ने सॉल्व किया है ना, टेस्ट में आया था एक बार, राइट? So what is correct answer here? D. Next problem. The mixture which shows positive deviation. See, this is very, very important question. Deviation from Raoult's law. Ethanol plus acid मैंने आपको अभी दिखाया था. तो यहाँ पे भी हमको positive deviation can ask or negative deviation can be asked. So which solution is showing positive deviation from Raoult's law? Ethanol plus acetone, benzene plus toluene, acetone plus chloroform, chloroethane plus bromoethane. So what will be the answer here? Mixture which shows positive deviation from Raoult's law. So mixture of ethanol and acetone here shows positive deviation from Raoult's law. Since in pure ethanol molecules are hydrogen bonded. You know that in ethanol molecules are what? Hydrogen bonded. On the other, on adding acetone, what happens is that its molecules get in between the ethanol molecule. Acetone molecules get in between the ethanol molecule, right? In between the ethanol molecule, and they break some of the hydrogen bonds present there. Okay, they break some of the hydrogen bonds present there, and due to this, there is a weak interaction between the ethanol molecules, and the solution shows positive deviation. And so the solution shows positive deviation. That's why the answer is what? Ethanol plus acetone, right? Do you get the idea? Yeah. Next. For ideal solution, the correct option is A, B, C, D. For ideal solution कैसे होना चाहिए? Delta H of mixing कैसे होना चाहिए? Delta V of mixing कैसे होना चाहिए? हम लोगों ने अभी देखा दोनों क्या होने चाहिए? 0. तो कहाँ पे 0? For an ideal solution, the correct option is delta H of mixing should be 0 and delta V of mixing should be 0. What is that correct answer? Yes. Right? So correct answer here is D. Delta H should be, delta H of mixing should be 0. यहाँ पे देखो ये नॉन जीरो कर दे, ये गलत हो गया. डेल्टा एस 0, ये भी गलत है. डेल्टा जी 0, ये भी गलत. ठीक है, तो हमारा आंसर हो गया D आंसर. The mixture that forms maximum boiling as a drop is, yeah. So what will be the answer here? Which will form a maximum boiling as a drop. So what is maximum boiling as a drops? They are formed by the solutions which shows negative deviations. They are formed by the solution which shows the negative deviation from Raoult's law. So here when you see na, acetone plus carbon disulfide, water plus nitric acid, heptane plus octane, and ethanol plus water. Here water plus nitric acid. Water plus nitric acid. These are showing negative deviation. H2O plus HNO3. H2O plus HNO3 are showing the negative deviation, and that's why they will show maximum boiling acetone. They will form the maximum boiling acetone. Okay. Next, which of the following statement is correct regarding a solution of two components A and B exhibiting positive deviation from ideal behavior? See, again, we need to find out positive deviation. Okay. So in case of positive deviation from Raoult's law, we have considered that AB interactions. What is there? AB interactions should be weaker than those of AA and BB interactions, right? AB interactions should be weaker than those of AA and BB interaction. So in this case, the intermolecular attractive forces between solute solvent molecules are weaker. ये अगर solute है, if this is a solute and this is a solvent, these forces are weaker, right? These forces are weaker than the individual solute and solvent forces. Okay, solvent molecules forces. So this means that in such solution, molecules of A or B will find it easier to escape than in pure state. So their escaping tendency is what? Maximum. Okay. So the escaping tendency is maximum. So this will increase the vapor pressure, due to which their vapor pressure is going to increase and result into the positive deviation. And that's why it will result into the positive deviation. So what do you think? Which of the following statement is correct? So statement 1, that is intermolecular forces between AA and BB are stronger than those for AB. Okay, than those for AB. Delta H of 0 at constant temperature and pressure नहीं होता है. ठीक है, पॉजिटिव डेविएशन में क्या होता है? ग्रेटर होता है ना. V 0 होता है क्या? ये भी 0 नहीं होता है. इंटरमोलिकुलर अट्रैक्टिव फोर्सेस बिटवीन A एंड BB आर इक्वल नहीं होते हैं, राइट? देन दैट विल बी द आइडियल सॉल्यूशन. ओके, दिस इज व्हाट पॉजिटिव डेविएशन आइडियल बिहेवियर. नेक्स्ट, which one of the following is incorrect? right? Incorrect. या इनकरेक्ट के लिए हमको क्या देखना है? अभी इनकरेक्ट फॉर आइडियल सॉल्यूशन. डेल्टा H मिक्सिंग इज 0, डेल्टा U मिक्सिंग इज 0, डेल्टा P is equal to like this, and delta G mix is 0. So for an ideal solution, what will be the case? क्या होना चाहिए? Yes, यहाँ पे हमको क्या देखना है? इनकरेक्ट देखना है. देखिए, इनकरेक्ट फॉर आइडियल सॉल्यूशन. सो वी नो दैट दिस शुड बी 0, दिस शुड बी 0 फॉर आइडियल सॉल्यूशन. सो ये दोनों गलत नहीं है. These are the true solution, true things, right? These are the true things. Now next is what? Pressure. So if delta H is 0, delta V is 0, then delta U will be again 0. ठीक है, delta U 0 होगा. सच में यहाँ पे नेक्स्ट है राउल्स लॉ. राउल्स लॉ के लिए क्या होता है? पार्शियल प्रेशर इज इक्वल टू x इनटू वेपर प्रेशर. पार्शियल प्रेशर इज इक्वल टू x इनटू वेपर प्रेशर फॉर AA एंड BB पार्टिकल्स. सो टोटल प्रेशर, जो चेंज इन प्रेशर होगा वो क्या होगा? P ऑब्जर्व माइनस P कैलकुलेटेड बाय राउल्स लॉ. सो दैट विल बी व्हाट? 0. दिस इज अगेन ट्रू. डेल्टा G क्या होगा? डेल्टा H तो 0 है. T डेल्टा S क्या है? डेल्टा S लेस देन 0 होगा, क्योंकि एंट्रोपी चेंज नहीं होगी. ठीक है, क्योंकि सॉल्यूशन मिक्स हो रहे हैं. सो वहां पे एंट्रोपी चेंज इज नॉट 0, एंड दैट्स व्हाई डेल्टा G विल नॉट बी 0. एंड दिस इज व्हाट? इनकरेक्ट स्टेटमेंट गिवन इन द ऑप्शन कि डेल्टा G भी 0 हो जाएगा. सो दैट इज नॉट करेक्ट. सो दैट वाज we need to find out. So our correct option is what here? Option number D. That was our correct option. Next problem. Yeah. Which of the following statement about the vapor over an ideal 1:1 molar mixture of benzene and toluene is correct? तो यहाँ पे हम लोगों को 4 दिए हुए हैं स्टेटमेंट्स. इनमें से हमको देखना है कि कौन सा स्टेटमेंट करेक्ट है. वेपर प्रेशर दिया हुआ है हमको बेंजीन एंड टोल्यून का. सो द वेपर विल कंटेन इक्वल अमाउंट्स ऑफ बेंजीन एंड टोल्यून. The vapor will contain equal amounts of benzene and toluene. Okay, whatever the vapor is present, it will contain equal amounts. Not enough information is given to make a prediction. Okay, that was another option. Next, the vapor will contain a higher percentage of benzene. Next, the vapor will contain higher percentage of toluene. So how to decide whether which one is correct? यहाँ पे हमको correct देखना है. Okay, so you know the formula. Pressure of benzene is equal to what? Mole fraction of benzene into what? Vapor pressure of a given benzene. Okay, toluene के लिए भी वही formula है. So for ideal gas, since it is 1:1 molar mixture of benzene and toluene, what will happen? The mole fraction will be what? Both का mole fraction or both mole fractions will be half. Okay, since both mole fractions are half, what will be the total pressure for benzene and pressure for toluene? They will be like this way, because vapor pressure हम लोगों को दिया था, मैंने वो values put किए. I've got the value of pressure for benzene and toluene right this way. So you can see here, if the vapor is formed from the 1:1 ideal solution, it will contain this much amount of benzene and this much amount of toluene. So which one is the highest concentration? Toluene का ज़्यादा है, benzene का ज़्यादा है. You can see that vapor will contain high percentage of benzene, as the partial vapor pressure for benzene is what? More as compared to the partial pressure for toluene. And that's why here our correct answer is option C. Right? That's why our correct option is option C. Very, very good question actually. ये question बहुत अच्छा था. इस तरह से आपको सिर्फ यहाँ पे there will be some changes in the solution only. Benzene, toluene, instead of these, there will be different solution can be present, and the same format question can be asked. Okay, very important. Next, which condition is not satisfied by an ideal solution? So for ideal solution, again the same type of question has been asked. Okay, for ideal solution we have talked that volume change of mixing should be 0. So this is correct. Again, we have talked that heat change of mixing should be 0. That is delta H should be 0. That is again correct. It should obey the Raoult's law. This is also correct. Delta S of mixing is never become 0. Okay, it will be non-zero. Okay, it will be what? Non-zero, delta S. So this is what incorrect statement or वही not satisfied पूछा है. तो यहाँ पे आंसर आ जाएगा option B. Okay, option B will be our correct answer. Next problem. Okay, let's solve for this. Next problem. The freezing point depression of benzene is. So qualitative property से question आया हुआ है. हमको freezing point का दिया हुआ है. Depression of molality दिया हुआ है. We need to calculate what? We need to calculate the delta TF, freezing point of depression of solution of molality containing non-electrolyte solution in benzene is. So हमको calculate करना है delta TF. Okay, what is the formula? Delta TF is equal to KF into M. And what is KF? That is what? Constant जो दिया हुआ है. Molality भी हम लोगों को दी हुई है. Just calculation करो, आपको आंसर मिल जाएगा. Very simple problem. See, I have calculated it. KF का वैल्यू पुट कर दिया और मोलैलिटी का वैल्यू पुट कर दिया, मुझे ये आंसर आ गया. दैट इज नियर टू 0.40 केल्विन. दैट इज ऑप्शन सी. राइट? सिंपल 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 प्रॉब्लम. वेरी सिंपल प्रॉब्लम. राइट? नेक्स्ट प्रॉब्लम. इफ मोलैलिटी ऑफ डाइल्यूट सॉल्यूशन इज डबल्ड. सी, इफ मोलैलिटी इज डबल्ड, द वैल्यू ऑफ molar depression constant will be. So if molality is double, what will happen to the KF? So if the molar depression constant is a constant for a particular solvent, thus it will be unchanged when molality of dilute solution is double. So it will be what? Unchanged. ठीक है, वो किस पे डिपेंड करता है? जो पर्टिकुलर सॉल्वेंट है उस पे वो डिपेंड करता है. Okay, and that's why it will be unchanged, the molality of a dilute solution whenever it will become double. Next, at 100 degrees Celsius, the vapor pressure of solution of 6.5 gram of solute in 100 gram of water is this much. The boiling point of the solution will be. So what will be the correct answer here? यहाँ पे हमको calculations करना है. So देखो calculation, weight हम लोगों को दिया हुआ है, right? One of the solute is 6.5, another solute is 100 gram. 100 gram of water. Okay. And what is given? Vapor pressure is given for solute, that is 732 mm. KB दिया हुआ है, TB भी दिया हुआ है. ठीक है, तो मैंने क्या किया? TB को डिग्री सेल्सियस और यहाँ पे क्या दिया हुआ है मुझे? पार्शियल प्रेशर. यू नो दैट इज व्हाट? 760 mm. So you know this lowering of vapor pressure formula. Just calculate these two things. You will good to go and find out the number of moles. Okay, number of moles मिल गए. आपको पता है अपना फॉर्मूला क्या है? Delta TB is equal to KB into M. So TB minus T0B, that is our delta TB, equal to KB. M क्या है हमारा? मोलैलिटी. मोलैलिटी मतलब क्या? नंबर ऑफ मोल्स डिवाइडेड बाय सॉल्वेंट इन ग्राम. ओके, सो यहाँ पे मैंने सारे वैल्यूज पुट कर दिए. ठीक है, पुट करो सारे वैल्यूज. या यू विल गेट द आंसर 101.06 डिग्री सेल्सियस. So that is C option. Right? Our option will be C. Okay, any doubt in this? Yes. Yeah, next problem. During osmosis, flow of water through a semi-permeable membrane is very, very simple problem. Okay, what is happening during osmosis? From solutions having lower concentration only, from solutions having higher concentration only, both the sides semi-permeable membrane with equal flow rates, or both the side semi-permeable membrane with unequal flow rates. So what will be the correct answer here? Your answer will be what? A. So during osmosis, flow of water through semi-permeable membrane takes place from solution of lower concentration to the solution of higher concentration. Right? Very easy question. Next, a 5% solution of cane sugar of isotonic with 1.1% solution of substance X. The molecular weight of X is. So यहाँ पे देखो हम लोगों को क्या निकालना है? मोलिकुलर वेट निकालना था. तो मुझे वेट दिया हुआ था 5%, तो मैंने उसको कन्वर्ट किया ग्राम में. ओके, अनदर सब्सटेंस एक्स का क्या है वेट? 1%, दैट इज 1 ग्राम. वॉल्यूम दिया हुआ है क्या? तो मैंने यहाँ पे वॉल्यूम कंसिडर किया है. दैट सॉल्यूशन इज आइसोटोनिक ना. सो वॉल्यूम इज व्हाट? सेम 100 ml 100 ml. सो 0.1 लीटर 0.1 लीटर. मॉलिक्यूलर वेट हमको केन शुगर का कैलकुलेट करके दिया हुआ है 342. दूसरे का मुझे पूछा है. सो फॉर आइसोटोनिक सॉल्यूशन concentrations are what? Same. So just use this formula. Okay, weight upon molecular weight into volume is equal to weight upon molecular weight into volume. So 1 1 1 2 2 2 कैलकुलेट करो, आपको m2 की वैल्यू मिल जाएगी. Okay, and that is our 68.4. Very good question, right? Good question. Next problem, क्या है next problem? The want of factor I for a dilute aqueous solution of strong electrolyte barium oxide is. So for barium oxide, we need to calculate the I value. क्या होगा? 0 1 2 3. So for barium oxide, as it is being what? As it is being a strong electrolyte, it undergoes into complete dissociation. उसका क्या होता है? Complete dissociation होता है. ठीक है? And that's why 100% dissociation होने के कारण उसके जो चार्जेस फॉर्म हो रहे हैं वो कितने हो रहे हैं? एक Ba2 plus और 2 OH minus. So total is what? Want of factor will be how much? 3. Okay? So answer will be 3. Next, the boiling point of 0.2 mole per kg solution of X is what? X in water is greater than the equimolar solution of Y in water. Which of the following statement is true in this case? So यहाँ पे हम लोगों को 4 केसेस दिए हुए हैं और कौन सी केस बराबर है वो हम लोगों को चूज करना है. Okay, so here what will be the correct option? C. Answer is what? Here our answer is what? Option C. X is undergoing into dissociation in water. X is undergoing into dissociation in water. So why is this happening? So देखो हमको क्या दिया हुआ है? Boiling point दिया हुआ है solution of X in Y, solution of X in water, which is greater than equimolar solution of Y in water. Okay, X का greater है than the Y. Okay, that why that is happening? Because first दिया हुआ है कि a molecular mass of X is less than molecular mass of Y. That is not true. Okay, that is not true. ऐसे नहीं होता है. ठीक है. Second option क्या दिया हुआ है हमको? Y is undergoing dissociation in water while X is undergoing no change. Okay, next X is undergoing into dissociation in water. Next, molar mass of X is greater than the molecular mass of Y. So हमेशा molecular mass और dissociation के बारे में बात की है. तो यहाँ पे आपको पता है फॉर्मूला क्या है? डेल्टा TB is equal to IKB into N. So for equimolar solution, what will happen? Elevation in boiling point will be higher if solution undergoes into dissociation. तो यहाँ पे equimolar solution दिया था, तो यहाँ पे क्या होगा? X should go into dissociation in water. Okay, that was our correct option. ठीक है. Next problem. On of the following 0.10 molar aqueous solution 0.10, or you can talk like 0.10 only. Okay, so that is the molality of aqueous solution. Which one will exhibit the largest freezing point depression? तो हमको 4 ऑप्शन दिए हुए हैं. इन 4 ऑप्शंस में से हमको पूछा है कि कौन हमको ज्यादा फ्रीजिंग पॉइंट डिप्रेशन देगा. तो हम वो कैसे निकालेंगे? बाय यूजिंग यू नो द फॉर्मूला डेल्टा TF is directly proportional to the want of factor. Okay, because the formula for freezing point depression is what? Delta TF is equal to I into KF into molality. हमको मोलालिटी दी हुई है सारे सॉल्यूशंस की जो सेम है. अगर मोलालिटी सेम है तो हमको किस पे डिपेंड करना पड़ेगा? वांट ऑफ फैक्टर पे डिपेंड करना पड़ेगा. तो सबके लिए वांट ऑफ फैक्टर निकालो. जिसका ज्यादा आएगा वो क्या होगा? उसके लिए फ्रीजिंग पॉइंट डिप्रेशन ज्यादा होगा बिकॉज इट इज डायरेक्टली रिलेटेड. सो लेट्स कैलकुलेट द वांट ऑफ फैक्टर फॉर ईच एंड एवरी कंपाउंड. So for KCl, want of factor is what? 2. For C6H12O6, want of factor is what? 1. For Al2SO4 thrice, the want of factor is what? 5. क्या करना है हमको? इसको अगर हम सॉल्यूशन में डालेंगे तो कितने आयंस मिलेंगे? 2. इसको अगर सॉल्यूशन में डालेंगे तो कितने आयंस मिलेंगे? वो मॉलिक्यूल है, उसमें आयंस मिलेगा नहीं. ठीक है, दैट इज नॉट अ आयोनिक कंपाउंड, राइट? ग्लूकोज इज दैट. ओके, सो वो एक ही मॉलिक्यूल होगा. अगर हम लोग Al2SO4 को डिसॉल्व करेंगे तो हमको क्या मिलेंगे? 2Al3 प्लस और 3SO4 2 माइनस मिलेंगे, राइट? सो दैट्स वाई यहाँ पे 5 हो गए वांट ऑफ फैक्टर. K2SO4 में क्या होगा? 2K प्लस और 1SO4 माइनस, दैट्स वाई 3 हो जाएंगे टोटल. सो किसमें ज्यादा हो रहे हैं? मैक्सिमम आई किसकी है? इसकी है. इसलिए इसके लिए हम लोगों को लार्जेस्ट फ्रीजिंग पॉइंट डिप्रेशन ऑब्जर्व करने को मिलेगा. दैट्स वाई आवर आंसर विल बी व्हाट? ऑप्शन सी. That is Al2SO4 thrice is going to observe or it is going to exhibit a largest freezing point depression. So in this way we need to calculate the want of factor. Okay, And this is the relation of it with the freezing point depression. So these are the certain problems I have summarized here. Try to solve more and more problems from solution chapter. Okay. If you have any doubt, you can ask me. Yes. Important है, ठीक है? Colligative property भी बहुत important है. Okay, anyone have any doubt? Okay, so let's meet tomorrow for the next session. Okay, try to solve more and more problems from solution. Mole concept, we have summarized everything about the mole concept. Right now, solutions, I have summarized around 10 to 12 problems. Okay, I think 10 to 12 problems were there. So I have tried to explain those to you. Try to solve more and more problems. If you have any doubts, you can send me the doubts also. Okay, and we will meet tomorrow for our next session. Okay, so thank you so much for joining in. Let's meet tomorrow.